Here is a fast little follow-up video on the AVO and testing different types of tubes. One of my visitors made a very interesting comment I really would like to follow up on, and that was please show us how to test some of the tubes, the diodes. And he's actually pointed out the EAA91 and another one that was the EAVC80. I don't have any EAVC80s, but that is a very, very interesting tube because it's a 3-in-1 tube. It's a triode, a double diode, and a single diode combined in one tube novel socket, exactly like this size here. And the thing is, it's actually connected with the double diode's cathode and the triode's cathode. They're connected together and all that kind of stuff, just to make it easier to make a radio. But what I think was the point of the question, that was actually double diodes with a common cathode and a real two individual diodes. So that is what we're going to go and test. I got the EZ80, and that is a double diode with a common cathode. But I think let's just jump straight to the EAA91 and then just follow everything through with that one. And then we're gonna go to the EZ80 and then follow everything with that one and see the difference. My first point is that the EAA91 is a small signal diode. Let's look at the specifications. It's of course 6.3 volt filament, and here you also see the pinout. You can see on the pinout that it is a true double diode, and there's even a shield in between the two diodes, and you can of course connect this to a ground or something like that to shield the two and to prevent any unwanted coupling from one diode to another diode. And also you will see that both of the two anodes and the two cathodes and everything is just completely rooted out, so you can do whatever you want with the two diodes. Let's look at the next page of the specifications, and that shows us the DC current. Maximum DC current is 9 milliamps per diode. That is quite low, right? And we can also see the 54 milliamp peak per diode, so that's actually quite high. So this of course allows us to charge capacitors and other stuff like that. So we can also see a curve for forward voltage and forward current expected in the diode. And that is very interesting to look at, and we're going to go back to that in a minute when we start setting up the tester for this particular tube. So here we go with the AVO. What I've done is I looked up in the manual for the settings, and in the manual they say the recommended settings for EAA91 is 192.311, and then there is an X and then 00. So, and this is more or less all they tell us, but there are actually a few more things we need to know when we want to test diodes, and that is the current. We need a current limiting, a way to limit the current, because this is a small signal tube and it can only handle the 9 milliamps. So that is definitely going to be a problem, because there is no current limiting ability in this unit. There's actually an anode volts, and then you normally control your tube, and then you measure the current. So if you want to measure diodes, what you need is you need to add a series diodes between your anode supply voltage to your tube, and then you'll know what the expected current will be. You can of course set up the voltage on the voltage dial here, and then you can change or you can select the resistors you want for this particular tube. So what I've done here in my case with the EAA91, I've taken a 2K2 resistor. I don't know if that is easy to see here really. Let me try and go a little bit closer. It's actually, it doesn't really matter which socket you take. Just take two of the next unused pins in the you know what I mean. This one is a 7-pin, and the B7G socket, that is for the EAA91, and that one only uses 7 pins. But I only need 2 pins for resistors. So yes, I could have used pin 8 and pin 9 in the novel socket, but my resistor here actually fits a little bit better in the compactron socket. So what I did is I just took pin, is that 10 and 11? So 10 and 11, I just connected my resistor, and here I assigned feature number 8 and feature number 9. That is the anode, and then the AD. So that is an internal signal that goes from that pin now, and that pin is now routed to the wanted pin in my socket for my tube. See, now it's a little bit confusing, right? Maybe you want to remember the pin outs of that tube, okay? So pin number 2 is anode 2. That is why I want to have this connection here on pin 2. So now I have my supply via a resistor, and then it is routed to pin 2, okay? So what I've done with all my cathodes, okay, so cathode 1 is pin 1. So that is connected to cathode. And the other cathode is on pin 5. That is of course cathode 2. And that is just also connected to cathode. So it doesn't really matter now which one of the 2 anodes I feed in something, then I will get the current out on cathode this or cathode that, right? So that is my goal here. Filament, that is pin 3 and pin 4. So that is also routed to those 2 heater features. Easy. And then we set it up for 6.3 volts and all that. So now I'm ready to perform the test, and we can now see that I am in this. All this has been explained in my previous video, so I'm not going to repeat all that here. We're just gonna check heater, so you'll see the, I don't know if that is visible when I have all this light here, but maybe you can see that. But of course the tube is heating up. So to enable the amp meter for anode current, of course I need to go into test. So the test mode is what you need, right? And then it's actually a little bit important to understand that the amp meter is only anode. It can only measure anode current, right? So now I have 10 milliamps of full range, so this is 6 milliamps, and my resistor is 2K2, and I have 12.6 volts supply voltage. So if you remember the curve we found in the specification sheet of this particular diode, you will see that it looks like we have actually some volts missing in the calculation, obviously. So that is why I want to repeat this using a normal DC supplies. So this is my 6.8 tiny little bit, right? And that is of course for my pin 2 anode. Okay, so let's try and test the other anode and see if it's the same. I actually prefer to turn it off while I'm changing this. See what I've done now? I have swapped. So pin 7, that is anode 1. And it is of course warming up. And in a little moment, we're going to see hopefully exactly the same. That means the forward voltage at 6 milliamp will be more or less the same. So that is the idea, to use as low voltage from your supply and as low resistor, of course, here as possible. And this way you will be measuring more of the forward voltage drop of your dual diode. I think this is a little bit complicated to do with this instrument. Of course, you can do this if you don't have any other instruments, and probably in 1960 this would have been pretty easy to do, right? But today I think this is a little bit too complicated. And also we didn't test all the different combinations, because it's really not that smart to do with this with this liquid tester here for this tube, to be honest. So because we don't assign all the other pins here, so we don't really have a way to measure if they are shorted and stuff like that. Of course, some of it will be found. So here's what I've done. I try not to touch it because everything here is actually connected correctly, and it is definitely working. So what you see down here is pin number 2. That is anode 2. Those two, that will be my filament. And here is cathode 2. So what I've done is I connected my EAA91 to my power supply here, and I limited my anode supply to 10 milliamps. And then I will turn on the filament, and then we will monitor what is going to happen. Of course, the current cannot go over 10 milliamps. What we want is we want to read out the forward voltage drop of that diode. Meanwhile, we can look at the specifications again, and then we'll see the curve. And now I'm turning on. So the tube is heating up, and it takes a little while for the cathode to be warm, but yes, we already got the current. So that means this tube is actually what I would call brand new. It's a little bit better. The forward voltage drop is a little bit lower, and that reveals a very good tube. If when they get older and older, you will see a higher and higher forward voltage drop at the listed current. According to the specifications, it is 2.5 volts at 10 milliamps. So that means we got a super duper good tube, and I'm very happy about that. And wouldn't you agree, this is a much easier way to do it, really? So let's try and do the same with my EZ80. And if you got an EZ80, please go and have a look at its internals here. You will see that there is a common heated cathode that goes all the way here. It's quite big diameter, and you'll see the two halves of the two anodes, they go around the half of the cathode, and so that is how it's made. It's I don't know if it's super easy to see here on this picture, really. And so yes, of course, this tube shares a common cathode. It's not going to make a big difference when we're testing on the AVO, because normally we'll just connect all the cathodes in parallel and then swap the different anodes. But here it's just one pin, and then that is super easy. This one, of course, because of its very big heated cathode here, it is 6.3 volts, but 600 milliamps. So now there's a lot more energy used to heat up the cathode. And let's look a little bit on the specifications. So this thing handles 90 milliamps constant DC, or the average, of course, right? And a peak currents up to 270 milliamps, and 500 volts is the maximum allowed peak reverse voltage. So it's actually what I would call a little bit more than medium power, man. You can really make a big unit with this, a lot of tubes and stuff, because of all that capability. And also, let's look at the next page in the specification. There is a curve, and here is something interesting. Now it is about 20 volts forward and 65 milliamps. So that means we're directly compatible with that here on the tube tester. So we don't need any series resistor. We can actually start with a lower voltage. The lowest we can do here is 12.6 volts, and then the next step is 20, 30, and so on, right? So let's just start with 12.6 and see if there's any action. And of course, if this is a shortage tube, remember your maximum limit here will be, I think it's a little bit more than 100 milliamps, and of course this tube can easily handle that. So so this way, yeah, we don't need anything else. So let's just plug this into the novel socket like that, and then let's inspect the settings for this tube. Here I show the recommended settings, and they are 901 230, that is correct, and then X00, and that is of course the other anode, and we're not testing that right now, so that's why it's an X. But of course it doesn't make sense to use the setting 9 for this, because we're not using an external resistor, or we don't want to route something around, and we want the anode to be used because the anode is connected to the amp meter in this unit. So I mean, it's a little bit crazy they didn't do that right. I'm not able to make it work with the recommended settings, of course. So let's try and fire up the tube and see what happens. So we are now in cold, and in cold mode, of course, we can check for leaks and blah blah blah, all the usual stuff. It's not interesting. Then we can heat up the tube and see if there's is there any light in the lamp. It is of course not so smart to have all this light here. Yes, we are getting a little bit of light, so now it's not so interesting to see that anymore anyways. Yeah, let's crank up the dial to test, and we're of course testing anode current, and it doesn't matter obviously where you have this, because we're measuring anode current, right? 100 milliamps full range, so it's a little bit under 40 milliamps at 12.6 volts. So let's give it 20 volts and see if it goes to 65. No, it goes a little bit over 65. So it's going like 70 something. So again, probably it's because my voltage is maybe a little bit too high, or it's because the forward voltage of this tube is a little bit lower. So that means it is a nice new tube. It's only a little bit dust on it and stuff like that. If it would have been a very old tube, you would see it appear very dark of old age. This is not the case with this one. So I actually think my forward voltage is nice and low. So what we can do is we can of course try the other diode. So we're going to change this. So now I swapped my anode from pin 1 to pin 7. And now we'll see current go up again, and hopefully it's gonna go to 70 something. See? Ooh, even a little bit better. Yeah. So that is directly compatible with this system. No resistors, no funny stuff, and I think that is quite all right to do it that way, really. Let's of course also test the EZ80 on a regular DC power supply. So what I believe I've done here is pin 1 is that. Yes, so pin 1 is the anode and pin 3 is the cathode. So then 4 and 5, that will be the filament. Okay, and that goes here to my power supply. Now I have upped the current rating of my filament, because this one we should expect about 600 milliamps. So that's interesting too. What I've done here is 30 volts and current limited at 65 milliamps. So what we hope to see is the 20 volts, or actually a little bit lower than that if we're a little bit lucky. So let's try and warm it up and see what happens. Of course the start up current is a little bit higher, and then it should probably stabilize us at around 600. And then yes, we see some emission and current goes up. Of course, we need to wait a few more minutes to see the final result. So here is my result. Well, it's actually still going down a little bit on anode 1. I believe this is pin 1. What we could do is just leave it powered up and carefully say, okay, it's 20.79 something, and going down slowly, right? Now I remove the anode from pin 1, and then I will carefully see if I can connect it to pin 7. Did that not happen? That is not happening. Seven. That's just because I'm really bad at counting. Sorry for that. See? So pin 7 is 20.33. So that was 7, and then I will quickly move it to pin 1. That is quite easy, and I don't need to count so much. Come on, man. And that one is a little bit higher. So there's a little bit of a difference in this tube. So that is funny. I got a few more I will try and play with now. And I was actually also able to test that tiny little difference on my AVO. It wasn't that loud and clear really. So I think you get a much higher resolution on your results by testing diodes with a regular DC power supply like that. It's actually super easy, isn't it? Just hook it up like that. You don't need any fancy smancy equipment to do that. Anyway, thank you very much for watching. I hope you're going to play a little bit with your diodes, and go ahead and test some diodes, different sizes and different types and all that kind of stuff. It's a lot of fun. Bye bye.